all the documentation features are in the Output Properties tab here. You can, just like any other BIM program, you can create views, sheets, and you can put views on sheets, and you can cut sections. A view is any model cut. It can be a section, a plan, an RCP. It doesn't really matter. Now, the interface for this is absolutely horrible, and it will be fixed. And there's a lot of work going on right now with the man who is the developer of Measure It, as well as Stephen, who is the developer of ArchiPack, who will get these, who are looking to help integrate these features with their features, which will make it a lot better. But I'll show you how it works right now. I create a view name and call it whatever I want. Let's call it whatever. And if I press the plus button, that creates a camera object. And a view correlates to a single orthogonal camera, which is automatically created. And you can see that it's created it at the 000 location, pointing down, cutting through my my cube object right through the middle, which gives me a plan view of my cube. And that also creates a views collection as well as an IFC group, and this allows you to save it out to the IFC file. Now, if I click on my camera over here, I now have the option to cut a section as well as set the scale, whether it's 1 to 100, 1 to 50, or whatever it happens to be. So if I click the cut section button, it has now cut a section. And that section can be viewed I'm going to open this up in Firefox, because that way I can view the SVGs which it generates. It's in the diagrams folder, BIM data diagrams. And you can see the whatever.png and whatever.svg. And if I click on that SVG, you can see a very tiny image, which hopefully if I zoom into it, you can see the rendered cube. And that's by default. All it does is it does a Blender render, and it does a bit of calculation to make sure that it's 1 to 100. So if I print out that SVG on a piece of paper, and that's a 2 meter cube, what's that, 20 mil or whatever it happens to be. I think 20 mil, 2 centimeters on a piece of paper. So if I change that to 1 to 50 and I press the cut section button again, and if I refresh this, that it doubles in size. And that's because now it's 1 to 50, so 20 mil, this cube, if I measure a 2 meter cube, I have to check. So that's not very impressive, because we don't really want to be rendering out our images. We want nice, clean vector cuts. Now, this is a bit of a strange workflow, but there is a reason behind it, and I'll describe why. So you have to, I'll just explain this a little bit more first. You'll notice that there's no vector geometry in here at the moment. And the way I've designed it is so that it will cut vector geometry from an IFC file, and then it will render out from the Blender file, which means that in order to do a section cut, you need to generate an IFC first. And this is an extra step, and it's very annoying for a small project if you just want to get something done, but it makes sense for a larger project, because for a large project, you will often have many IFC files, often hundreds of megabytes, coming from many different programs from many different stakeholders. And so it does not make sense to bring it all through Blender just to create documentation. You want to keep it isolated. At the same time, you want to guarantee, for contractual reasons, that the documentation is extracted directly from the IFC file. More and more common these days, there is a requirement for documentation to be taken from the model and not just as separate 2D line work. And it's almost impossible to guarantee that, and nobody ever does it. Even schedules, they struggle to do it. There's a lot of fuffing around that happens. But sort of moving towards a more ideal future, where the documentation and the model are truly synchronized, it is important to guarantee that sections are taken directly from IFC. And that means that this feature can actually run without Blender. It can run on a server, for example, and that way you can automatically generate documentation from a server. So if I take my cube, and if I export, we'll call it tested IFC, and you can see it's generated my structure for me, and I click Add IFC file here, and I browse to my test.ifc here. Now, if I click my cut section again, you can see a black with Inkscape, and you can see what it's done. So that is a true cut polygon. It's vector, it's nice and crisp, and behind it, peekaboo, is the Blender render as a raster background. And this compromise I've done, where the section cut objects is vector and the background is Blender, allows for a few powerful things. The first is that cutting from an IFC is a slow process. The geometry in IFC is not, let's say, optimized for cutting, and so it may take a very long time. And often there are many objects in the background you just don't need to cut. So for now, the default option is to just render out a raster background. And for most scenarios, that's okay, because for most documentation, the bits which you need to be vector, the bits which need to be hatched in and needs to be measured and checked in vector programs are the section cut itself, not the things in the background of the image. Now, this gray background is particularly annoying, but it just uses your default Blender rendering settings. So you just tweak it to whatever you want, and that will change with it. You will notice that the rendering engine it uses is actually is whatever you choose, but I have set 2 presets here, and these are very badly coded presets, because what it does is it changes your rendering settings, but it doesn't let you change it back to what it had before. So it's a one-way trip, and in the future we'll have a proper system which records your graphic settings on a view-by-view basis. But right now that feature does not exist yet. So if you're on a small project where you're okay to tweak it slightly view by view, that's fine. On a bigger project, it's just impractical at the moment. So if I click that button, it's actually changed my render settings to be this nice sort of pure white sort of SketchUp style view. And this is, I find, quite good for early concept stage documentation. There's also this button you can press which will change it to more construction style line work drawings. So if I've changed it to the construction style one, and if I, again, active camera cut section, you can see there's my rasterized background. So if I now have 2 cubes, and one will be cut by the camera, one will not be cut by the camera. Let's increase the size of that so I can see both of them in my image. Now, if I cut the section one more time, and I'll need to reopen that file, you can see I have one nice crisp line shown in the background, one cube which is cut. Now, that cut object at the moment is shaded with a solid black. And the way it works is that every single object has classes applied to it. And this is different from traditional documentation. In traditional documentation, you create your vector cut, and that's it. It's set in stone, you can't change it. And it stores the line weights, the line styles, and all that, end of story. In this approach, where we create an SVG, it's slightly different. It stores semantic information. So for example, that particular polygon is this polygon here. And it not just knows it's a polygon, it knows it's a cut polygon, so it's a part of the section cut. It knows the IFC class, it knows the ID, and it knows the material. You can see that this ID will correspond to that particular object's ID over here, and the material will correspond to the material name over here. And it has a series of points, but it doesn't store, but that's it. It doesn't store any information about that it's a black filled in solid. All it's actually specified with CSS. And BlenderBIM comes with a set of CSS definitions out of the box. And that's pretty powerful because if, for example, change my thing to concrete, my material to concrete, and let's export that IFC out one more time. Again, you can see why this step can get annoying pretty quick. And if I refresh the file, you can see now it has a concrete hatching applied to it. And it's applied at runtime. So that way, you can view it on anything, a phone, a tablet, anything which has a browser will be able to view your documentation. You don't need expensive CAD software. It's applied at runtime, so you can actually turn on and off objects. You can have one plan be generated and use the same plan again and again with CSS styles for a fire plan, a furniture plan, a wall types plan, and so on and so forth. So it's quite a powerful system, and it's also queryable. So you can actually write XPath code, which can say, hey, show me all the documentation which has this element in it, or show me all the documentation which has concrete in it, or check that all the spaces in this documentation are, also have a fire-rated wall or something like that. So it's quite a powerful feature that you can actually query documentation as a data set that you can't do with the traditional way of doing things. You can also create annotation. So if I press the dim button, that will create a new curve object, and there's nothing special about this. I could have fully well done, add curve, whatever, Bezier, circle, maybe not a circle. It kind of does need to be a strap tools. That's very useful. Snap, and you can see that this curve is just a curve in 3D. I can move it around in 3D wherever I want. And that will store the 2 points required for a dimension. Now, at the moment, you can see it doesn't actually look like a dimension, and it doesn't show you the dimension, and that's kind of bad. But with the work we're doing right now with Kevin, all that should be improved. So if I press cut section again, you can now see a dimension line. And the dimension is automatically filled out using proper, the proper typeface for technical lettering, as well as the architectural tick marks. And again, if I refresh that, you'll see that it's a line which knows it's an annotation, it knows it's a dimension, and this is garbage that I need to remove from my code. But all it stores is, a start coordinate and an end coordinate. It doesn't actually store all of the magic of how these tick marks work. That's stored again with CSS and applied on runtime. So you can very easily switch between different annotative styles. If you don't want a tick mark, if you want arrows like for an engineering drawing, or if you want something else, you can just apply it with CSS. And this works for anything, whether it's a section label or whatever. And that's kind of it gives you a lot of flexibility. And this is just plain SVG, and nothing special about this. You can open up Inkscape and you can edit it. You can also define. Here you can see the dimension, start and ends. These 3 lines define the 3 lines to create the architectural tick. And you can edit these with Inkscape and create your own funky styles. Everything is normalized to millimeters using the metric standards for hatching. So line weights are things like 0.25, 0.35 pen thicknesses, you can see there. So you don't need to do any fancy SVG math. It's already worked out for you. And if you want to do it in SVG, you just stick to these easy numbers. These will tell you the width in millimeters. So everything is in millimeters. There's not much support, zero support for metric at the moment. Sorry, for imperial at the moment. So everything is normalized into SI units. And all of these definitions are, again, in that data folder. So you can see there is a styles folder, and inside this default.styles, this is all. So if you edit this file, your documentation will have the CSS applied to all of it. And if I edit the templates, you can see there's a series of SVG files. It has a marker file for all leaders and arrows and things like that, a patterns file for all hatches. There is a series of hatches like concrete and diagonals and things like that. Symbols for things like section, rectangles and labels and things like that. A title block, which I'll show you in a short while, and a view title, which I will also show in a short while. And this is all just regular SVG, nothing magical whatsoever. You can design it in whatever program you want. So you can create as many as you want, and I'll just show how. Whoops, where is my Firefox? Okay, if I wanted the text to be on the other side, that's defined by the curve directionality. So I can switch the direction of that curve object, and if I cut it again, you can see that it has been switched. So you do get a bit of control over it. And those annotations at the moment are not smart annotations. So if I move this, for example, the annotation does not move with it. And so it's very tedious for a big project and impractical, I would say. But again, this is something that's currently being worked on so that if you move one, the other one moves with it. And there's smart ways to associate annotations. They're not tied to any geometry, so I can sort of arbitrarily create some dimensions out in the middle of nowhere. And you can see the results. And the numbers are updated dynamically. Now, if I change the scale, all of this will also update automatically. So you can see that it maintains the appropriate line thicknesses and line and text dimensions as per the metric standards. And this is configurable, but not in the UI. So at the moment, I've chosen the defaults. This, by the way, a quick one here. The text itself comes from a font here in the fonts folder. You might want to install that on your system to get the nice technical lettering. So we'll change that back to 1 to 50, cut a section. I'll give you a brief sample of the other types of things. You can add an equal dimension, which basically is a regular dimension, but rather than giving you a number, it will just say an equal. You can type in text, so I can say, that's not particularly visible, is it? Where's my text object? Hello, there it is. So white on white text objects never fun. So let's give text a color, shall we? Make it black. So there we have our text object. So by default, it will again maintain the proper text sizes. And if I click on that text object, I have a series of properties. I can say its alignment, and it will respect that. I can say the font size. So whether it's, at the moment, it defaults to a regular font. And these are pretty much the standard font sizes used in metric documentation. So If I make it smaller, you can see it shrinks. If I make it larger, you can see it grows. And these correspond to the view scale as well. So for example, if I make that large and if I make that title sized, you can see that it will come out at exactly 2.5, 3.5, and 7 millimeters size if I print that out. If I change the view scale to 1 to 20, for example, you'll notice the text size doesn't change. At the moment, there's this very annoying button you have to press called resize text, which will recalculate it. And now it will be the appropriate size for that view scale. Let's take it back to 1 to 50, which looked a bit nicer. There are a few buttons you can play with here. Should recut determines whether or not it looks at the IFC file and cuts the object again. Should render determines whether or not it replaces the background image. And should extract is if you have a particular bit of annotation which grabs data from the model itself. I'll just check for questions. Bruno's question about, yes, it is currently not possible to create an elevation or isometric as vector. You're absolutely correct. It is not possible at the moment. However, there is work being done with Kevin to change this. And so he has certain approaches to get some vector output, which could make it possible in the future. It's not currently working at the moment. There is actually code which does what you're talking about from the IFC. However, I have disabled it. The code is still there. I haven't deleted it, but I've disabled it simply because the performance right now is just not good enough. So it takes a long time. I'll talk about representations in a bit, in just a short while. I'll just finish off what can be done with documentation. Stair arrows is, well, I guess a stair arrow, nothing special about that. A leader is basically, if this were pointing at something, let's move that there. And again, the directionality of these curves matter. So if I go and cut this one more time, you can see I now have, let's make that proper size. I now have an arrow pointing at that. I have a stair arrow over there. And again, the leader doesn't associate with the text, which is another kind of a bad thing. But it's just, this is all sort of rough and ready features at the moment. It has been used to deliver a project, so you can do it painfully. But so the fundamentals are there, but there's a lot of workflow which needs to be improved. A level, we're in a plan view right now. I'll show you both as well. So a level lets you, let's turn on some snapping. Let's say, do that. And what this does is you'll notice it's in 3D. So this is a -1 right now in the Z-axis. And the Z-axis is taken to be the RL. Excuse me. So you can see that it's generated the RL. As there is a dot in there, 1.000, which is the sort of standard notation for RLs. The directionality is wrong, so I can swap the direction and see the result. Then there is also a level section. So this one will probably be best rotated. And I'll show you what this doesn't really make sense in a plan because we're all in Z -1, but in a section, if you had multiple. So for example, I can do that artificially in 3D. Let's move that up and move that up by, we're going to move our camera so we can get it in the view. you can see the RLs are calculated properly. Now, it's important to put it on a sheet. So default, again, in data directory, there is a sheets folder, as well as a template. So remember that title block I mentioned? That's where it comes in use. If I create a new sheet, and that's in here, and I press plus, and I can see the list of my sheets in there. It just detects what you have in your folder. By the way, if you're on a program, if you have set up your default SVG program, you can press these buttons as well. Pressing this button will take you to the view like that. So I can drop down to my view and press the button. And pressing this button will open that view in your default SVG program. I haven't set that up on my computer, so it doesn't work on my computer, but on other computers which you do have it set up, it should work. So if I press that, I will get this image editing program, which doesn't view SVGs quite so correctly. But on your computer, it should work better. That way you don't need to do what I did in Firefox and browse to it. So now I can see I have an available sheet, and what that's done is it's created in the sheets folder, whatever sheet, and it's automatically placed the title block on it. And if I view the source code for it, you can see it's basically empty. And that's because all the sheet is including other embedded SVGs within it. And that way you can just reorganize things on your sheets, and all your other SVGs are dynamically linked. And so if you edit one title block template, it will update across all of your sheets and views and all the rest of it. So if I want to add a view to my sheet, I click the appropriate view, click the appropriate sheet, click add view to sheet, and you can see now that there's a little bit more in that file, and it has added my view onto the sheet. And at the moment, it adds it to the top left, which is probably not what you want to do because everybody wants to move it. And all you can, and this is just a regular SVG. Again, no magic happening here. So there it is. And you can take that and you can organize it on your sheet. This is inside a group. So if I want, I can go inside the group and I can click just that view, and I can sort of reposition that where I want. And let's say I just want to move it like that. Oops, sorry. Let's move out of my view. There we go. Just put it like that. And you'll notice that, and now Inkscape shows it as rasterized, but it is not rasterized. It is actually maintaining its vector. And this view scale, this view template, this view title template, again, is another SVG, which I mentioned before in the templates folder. That's the view title. Again, you can customize it, just plain old SVG. However, you'll notice that it has little template tags, number, name, and scale. And similarly, on this title block somewhere, I'll have to check. I think it has some of these templates set up. And what that means is that it gets generated on the fly. And this is in preparation for in the future where we have revision control and doing all that type of naming automatically. So if I press the Create Sheets button, that will fill in all of those templates. So you can press this button to view the created sheet, but like I said, that's not working on my computer. It should work on yours though. And it bundles all of the embedded SVGs into here, and it's created. Oh, I didn't press save in my Inkscape. I should have pressed save. I'll press save now and regenerate the sheet. Okay, there we go. Now that I press save, and you can see that it's actually filled in number one because it's the first view on the sheet. It's filled in the view title, and it's filled in the scale appropriately. It's also filled in the sheet name at the bottom right, the drawing number, and the revision A by default. There is currently no system which updates this, but that's visible in the UI, but the groundwork is there. And you can keep on placing more and more views on a sheet. So hopefully that might be useful. I will give an example of documentation which has been produced with it. I think that's this one here. So you can see this uses the exact same techniques. Our hatching's done with SVG. That's a nice vector. You can see things in the background are rasterized. This is a low resolution rasterization, just because I used it for a test. But you can see the type of output you can get. Now, this data is actually smart data. It comes from the IFC itself. Now, I will demonstrate that. So if I have a particular piece of text, I can associate that text with an object. So for example, this cube. Once it's associated, I can add variables. So I can add a name to that variable. So I can call it ASDF, and I can give it a property key. And a property key lets me reference a piece of metadata associated with this object. So for example, this object has attributes. It has at the moment, it's only got a global ID, so it hasn't got much info. But let's reference that. So I can say property key is global ID. Now, because my variable name is ASDF, I can do that. And when I cut my section, it will, which I've closed it. You can see it has dynamically extracted that piece of information and replaced my variable. And that way you can have smart tags associated with objects. So you can select multiple objects all at once, and you can go and click on the text button, and that actually creates, that one's hidden by the cube. Let's move out of render mode. That creates multiple text objects at the geometric center of the objects that you previously selected. And that's pretty useful if you want to bulk tag objects. So now what I can do is I can select one of my text objects, and let's say we want it fully centered, and I can right click on that, and I can copy to selected. Yep. And I can add a variable to one of them. So let's say, and by the way, if I select them and then add the text, you can see they're automatically associated with their particular object. So now if I go and add a variable and I do the same thing, we'll call it, I call my variable name hello, and I give it a property ID of global ID. You can reference any piece of metadata, any property, any quantity. And then let's edit that and say hello as a variable. There should be a button here to click propagate text data, and that will mirror your tag style to other tags. And so now, if I cut the section one more time, you can see that both of them are centered and dynamically getting data about their respective cubes. And that allows me very quickly, especially in this piece of this demonstration, to tag every single room with their respective IFC data instead of typing them one by one. I should mention grids, because grids is not exposed in the UI. No, it's not. I think, could be wrong here, I have to check. Grid is just a simple mesh edge, and you place that mesh edge in your group for the view, and you can call that IFC. I think for now it's just IFC grid, and you give it the name of the grid. That needs to be fixed to get the properly stored grid axes. But now, if I load that one more time, you can see that's my grid A over there. and I duplicate the object, and we'll call this one grid B. Rotate that, scale it down a little bit. 01, 02. There you go, and there we have some grids. Representations. So that's pretty much it for documentation. To make things faster on a bigger project, you should disable recutting whenever you're not actually changing what's being cut. That will make it a lot faster. You can disable rendering as well. And if you're not changing the data and you're just moving around annotative lines, you can also remove should extract. And it's an instantaneous thing. I can click it multiple times and it just happens. There's no processing time required.